Hello everyone, I hope you're enjoying JNUC 2022. My name is Jeff Barco, and I'm responsible for an engineering and development team at Stanford University. We support device management for over 100,000 devices across all types, and we also develop software applications. Today, I'd like to talk to you about the experience of bringing Jamf to Stanford. But first, let's talk about the Stanford landscape, as it might help to familiarize you with higher education and explain our critical decisions along the way. At Stanford, we have 7 schools that make up our university. While each of these schools is similar in their mission to extend knowledge, they're unique in their technological approaches. So what that translates to is localized IT support to sustain individual needs of that school. This landscape means both distributed and centralized device management is required, which might help explain why we use Jamf Sites so heavily. Sites are components that Jamf Pro administrators can create to determine which objects Jamf Pro users can view and manage. In addition to the 7 schools that make up the university, it's also associated with 2 health systems. We have 1 adult and 1 children's hospital. They have their Jamf instances, but we must coordinate. For example, when faculty or staff move between the university and health systems, they want a seamless device management experience. I share all of this because it's helpful to understand that Stanford is a culmination of different schools, programs, hospitals, and research centers with differing needs regarding device management. Now, let's talk about the people who make up Stanford. It's no surprise that we have a lot of students who come from across the world for education, but we also have a lot of researchers. We have a lot of researchers because Stanford is an R1 research institution, meaning Stanford must remain at the forefront of research and innovation. So, supporting these different populations means different device management requirements. It also means a lot of IT staff, roughly 1,500. 40% are part of central IT, and 60% are part of distributed IT, sitting within the schools. This distribution of IT support is vital to understand when we're designing solutions. We're thinking about the experience of the end population, and we're thinking about the IT staff supporting them. Finally, all of these people need devices. That's why we're all here, aren't we? And at Stanford University, we have almost 60,000 Apple devices to manage, not including the health systems. We currently have over 20,000 enrolled computers with a target of 35,000. And thanks to our mobile migration efforts, we have over 22,000 enrolled mobile devices. With all of these devices, our solutions must scale without sacrificing user experience. Here's a glance at what it has taken and what it is taking to bring Jamf to Stanford. You may have seen us talk about some of these things last year at JNUC 2021. If you haven't, I'd recommend checking that out. We've had to engineer workflows, integrations, and custom applications, like DataGator, a service for watching and remediating changes to the device, or Cardinal Connector, a Jamf automation and webhook assistant that feeds our device compliance database for a unified view of all our device types at the university. And then there's SiteMapper, a tool that uses organizational attributes to determine what site a device should belong to, so distributed administrators can manage their devices. We'll go into more details about that soon. We've also had to execute major projects. For example, we're currently closing out our deployment of Jamf to our macOS devices and just finished migrating our mobile devices. Higher education is a complex environment, so more often than not, we have to look outside of the box. Take our macOS Jamf enrollment application. We created a desktop application that guides the user through user-initiated enrollment. This application helps improve the success of enrollment while providing transparency. For our users, privacy is paramount, so it's important to share what Jamf will be doing on the device. We let them know what Jamf can and cannot see or do on their device. As I mentioned, creating a good user experience is essential. One where we must streamline complicated tasks, removing the burden from support staff to assist. For example, on this screen, we provide instructions with screenshots to install the profile, then link directly to the profile's pane, checking to see if they successfully installed the profile. And similarly, on the mobile device, we wanted to create a good user experience with a high success rate, especially since we had to migrate over 20,000 mobile devices from our previous MDM to Jamf, an involved project we'll dive into more later. For this effort, we also needed to migrate to modern authentication for the mail account, meaning people would lose their mail, contacts, and calendars if the migration didn't go right. So, we deployed this migrate app with our previous MDM. The app would unenroll you from one MDM and simplify enrolling in Jamf. We aim to limit the cognitive load required to move forward by providing information along with each screen. And while it wasn't perfect, it significantly reduced the support burden over manually performing the steps of a mobile MDM migration. And speaking about support, joining me today, we have a few of the key people critical to the success of these efforts. You'll hear from Trina Glidden, Project Manager, Forrester Terry, Software Developer Lead, and Sam Zamville, Systems Engineer. Trina, do you want to take it away?
Hi everyone, I'm Trina Glidden, an IT Project Manager working in the Stanford University IT office. As we heard from Jeff's overview of our unique Stanford landscape, keeping the Stanford community of over 30,000 people and 60,000 devices secure and compliant requires an immense amount of planning, coordination, and communication across a multitude of units and channels. Today I'm going to share with you our most recent retrospective for the Jamf iOS migration project. At the end of 2021, this team took on the lofty project goal of migrating over 26,000 iOS devices spread across over 30 distributed groups and units from our prior mobile device management system to Jamf in just 6 to 8 months. I'll dive into the details of our 4-phased implementation approach and share with you the lessons we learned that we hope can inform your future projects. When I joined the project, the team was wrapping up the development and deployment of a never-before-seen custom migrate app to help streamline the migration to Jamf. Given the sheer number of devices to migrate, and since this new app had never been tested or deployed at scale, a pilot phase was crucial. During this phase, we planned to target friendly groups, such as my unit, University IT, as well as proactively invite other distributed units to migrate early. We went on roadshows to show the app and provide access to it. Next was the migration phase. This is where we would target all iOS devices with the prior MDM installed that were checking in as active at least within the last 30 days. We'd notify the owners of those devices of the upcoming push of the migration app to their device and provide instructions of how to install and deploy it successfully. And if they wanted to migrate early, we offered a web-based approach to migrate. So these first 2 phases were our early adopters. But then there are your laggards. The 3rd phase, or enforcement phase, was reserved for those ignoring our weekly pushes or our email reminders. Here we would force removal of the MDM profile so the device would become unmanaged and, as a result, non-compliant with Stanford policy. Users would start receiving additional emails or notices of noncompliance and likely could lose access to important services that they enjoyed, such as email, calendar, and contacts, until they'd installed Jamf. Lastly, our fourth phase was reserved for cleanup. We knew we had several thousand devices that weren't checking in but still had the prior MDM profile installed, so this is the phase where we would purge them from the system. We also planned to handle any granted exceptions during this phase. So the implementation of these 4 phases was set to span over 6 to 8 months, but we weren't quite sure how long we needed for each phase. So let's see exactly how it played out. During the pilot phase, or that premiere of the never-before-seen Migrate app, users had to migrate to our Stanford app catalog, select to install the app, and then run it from their device, a pull approach. And as a result, we unfortunately didn't see too many adopters. Only 2,800 devices migrated to Jamf. And at this pace, we would not reach our goal of 6 to 8 months. So in February, we switched to phase 2, our imposed migration phase. This is where we did weekly pushes of the Migrate app to devices across a group of planned units. A user would receive a pop-up like this one, ideally click install, and then run the Migrate app. During this phase, we were targeting over 18,000 active devices, and we performed weekly pushes with advanced email notifications and reminders. Yet, still only an additional 6,000 devices migrated. People were either canceling the push app or installing the app but just not running it. So our laggards were left. We switched to our enforcement phase. Here we automated the removal of the prior MDM profile, leaving the device unmanaged and potentially uncompliant. And as you see, that is what did the trick. Just under 10,000 devices migrated in 2 months. So now we were ready for cleanup. The devices remaining in our prior MDM were inactive, so could be purged. And we didn't have to handle as many exceptions as we expected. But look at the continued Jamf enrollments despite our team ceasing proactive Migrate app pushes and sending of weekly email reminders during this phase. Our compliance engine was what took over. Compliance emails and likely the loss of services resulted in additional 3,000 enrollments. And we're still climbing. So what are the key lessons learned? We had 4. Automate, communicate, measure, and reflect. Automate. I personally was skeptical about the large investment of time and effort we spent building the custom Migrate app, as users could complete this same migration with 27 clicks using a web-based approach and iOS native functionality. But the Migrate app still required 21 clicks to complete the same task. But because it made the steps seamless to the user, the removal of the old profile and installing of the new profile, this investment was well worth it. Over half of the 20,000 migrations were completed using the custom Migrate app. Communicate. In addition to the proactive emails and reminders we were sending out, we created a detailed project page which contained valuable content such as FAQs and how-to videos, all of which that received 8,000 unique views. Our project page itself received over 22,000 unique hits. So having a dedicated project page or home that we could point anyone to that was affected by this migration allowed us to quickly publish and update content as we learn more during each phase. Measure. As mentioned before, this migration affected over 30 distributed unit and groups, and they needed to track their status, especially the distributed IT staff, as they were often the first line of triage to provide support should anything go wrong during migration. This real-time dashboard provided drill-down analytics by unit of how many and which devices were in our prior MDM versus those in Jamf, letting groups visualize their progress over time. Finally, reflect. It may not have been apparent from the prior implementation slide, but we built in several weeks to pause, review the metrics, and adjust our migration approach. For example, before moving into the enforcement phase, we paused to review our present strategy of deploying the Migrate app to specific unit or groups at a time. We knew the enforcement phase would impact the most people, and we wanted to be sensitive to that. We analyzed the remaining devices, group together those that had the least impact on the owner as a result of becoming unmanaged during the enforcement phase, and put those into the first month. Those that had a higher risk of impact, such as losing services of mail or calendar, we put those into the second month, thereby giving as much lead time for our communication efforts to encourage action versus punishment. Without building in these pauses of reflection, we could have greatly upset several groups. And it also had a side benefit of giving our support teams a nice break here and there, as overseeing weekly activities and handling support tickets across 8 consecutive months is exhausting. In conclusion, our 4-phased approach of pilot, migration, enforcement, and cleanup, along with key pillars of automation, communication, measuring, and reflecting, were pivotal to our success that we are taking forward to future migration projects. Now that you've heard in great detail our iOS Jamf migration story and retrospective, let's hear more about several of the benefits and innovations Stanford is currently enjoying by using Jamf. Thank you.
Hi, my name is Forrester Terry, and I'm a software developer lead at Stanford University. Today I want to talk about a tool that we made using the Jamf API and Jamf webhooks called SiteMapper. SiteMapper is a Python script that automatically moves devices into a site based on user information. The reason we wanted to build this tool is because Stanford has a lot of different local IT groups wanting control over their own stuff. By giving each IT group their own Jamf site, they can keep their devices and content separate. However, existing methods for moving computers into sites in an ongoing manner was too manual, so we decided to build our own workflow. I'm hoping by showing how this works, you guys will actually be inspired to use the Jamf API and Jamf webhooks and explore what you can do with it. But let's first talk about how SiteMapper works. It all starts off when the device does a send inventory. The send inventory triggers a webhook on the Jamf server. And what this webhook does is it sends information about the computer or the device to our Python script. And our Python script will attempt to identify the correct site for the device that just checked in. Once it's identified the correct site, it's going to move the device into that site using the Jamf API. And essentially this is an ongoing process, so anytime a device does a send inventory, it'll check in with our Python script and see if it's in the correct site. So how did this work out for us? It actually worked out pretty well. SiteMapper has been running in production for over a year, and we've actually had no bugs or issues. If anything, we've just focused on expanding features. We've had over 20,000 devices automatically moved into a site thanks to SiteMapper, and it saved a lot of time for our technicians and admins. No time was spent figuring out the proper site for the user or the device. No time was spent maintaining a bunch of pre-stage enrollment profiles. No time was spent moving devices around manually from site to site. And then any device that joins the Jamf server is going to automatically end up in the correct site and start inheriting all of the configurations that it needs. With over 50,000 devices in our environment, this is a very much needed tool. We have 17 different IT groups, each with their own site, utilizing this workflow so far. And the cost has been very low. It's only been $117.87 per year, and this includes all of the hosting for the Python script and all of the traffic to it and whatnot. In terms of effort, for people, we had a junior developer who was familiar with Python, and then we had a couple of Jamf admins and desktop support technicians. In terms of time, for both development and testing, it took 2 weeks, and the biggest thing for us was following the software development lifecycle. That is depicted on the right here by this graph, or this chart rather. It is essentially a process that starts with requirements and analysis up there at the top. This is where you define what you want to build, and you define the scope of what you're building. The second thing you do is design. This is where you define how it should look and what it should do. And you can also break your project down into smaller tasks by figuring out all the small pieces that will make up your overall process. Once you have all that figured out, you can move into implementation, which is where you actually develop and tweak your process, workflow, or app. After that, you do some testing, test and revise. And then finally, in evolution, that's where you're releasing it, and then you're also maintaining it, making sure that it's staying up to date and it stays working. Following this process allowed us to quickly get things built because we knew exactly what we were building, and we essentially had everything just laid out. But there's something I want to emphasize is that you don't need to be a developer to build cool automations. We chose Python, Google Cloud, and etc. to make our workflow happen. However, there's other tools out there that are really easy to use, such as Zapier. Zapier is a no-code tool that allows you to create automation workflows and integrates with thousands of apps and services. It even has an integration with Jamf. In conclusion, I want to again talk about the Jamf API as well as webhooks. Both of these things are incredibly powerful when paired together. You can use the Jamf API or Zapier to build your automations. You can do things such as deleting a computer record with the Jamf API, or you could send a Slack message to a channel using Zapier. Webhooks allow you to trigger your automations or workflows. These triggers can be things such as a device being added to a smart group, or a device joins your Jamf server for the first time. Pair the two together, you can have yourself a workflow where, okay, a device joins the Jamf server, then you send a Slack message to a channel using Zapier. Or a device is added to a smart group, you use the Jamf API to delete the computer record, and then there you go. So what I would say is, think of something at your job that is tedious or time-consuming. Break that task down into manual steps, and then see if the Jamf API or Zapier offers a way to automate any of those steps. You might be surprised what you can actually automate in some of the time that you'll save. But that's it for this section. I'm going to go ahead and turn it over to Sam, where he's going to talk a little bit more about some of our workflows and some of the other things that we've implemented.
Hello, my name is Samuel Zambo. I'm a systems engineer on the Endpoint Engineering and Development team at Stanford University. I'm going to be talking about continuous integration, continuous delivery for device management. The diagram you see is made from an infinity loop. It's a very typical DevOps lifecycle diagram. Like the software development lifecycle Forrester showed you earlier, CI/CD is a development principle which can be utilized and adopted by systems engineers. The diagram can look a bit confusing at first, but the idea here is that we start at the plan step and move through the loop, each step being a defined phase which generalizes what we're doing at any point during a project. The infinity loop is used to symbolize that software development is never finished. And like the never-ending cycle of development, in systems engineering, there are always things we utilize in our environment which require frequent modification, testing, and deployment. So it makes sense to adopt development principles like CI/CD, which will help facilitate these operations. CI/CD is almost always mentioned in conjunction with the term pipeline. What is a DevOps pipeline? Well, it's the automation built to facilitate CI/CD, and with it comes tons of really cool tools. At Stanford, we use some of these tools to automate the modification and deployment of a configuration profile. However, what I'm going to be talking about can be molded to enhance the lifecycle of many systems engineering processes. So, what does integrating CI/CD automation get us? Well, it mitigates human error. It can validate configurations. It includes a clear testing phase where we can easily visualize changes. We're able to reject bad updates and revert changes. We can build in logging, auditing, communications, and alerting. It gives us controls which prevent us from deploying changes directly to production. And best of all, it reduces time. I'd like to take a second to show some of the tools that we use. Thanks to Jamf's robust and well-documented API, we as engineers are enabled to extend the platform with custom integrations, like the automation of a configuration change. But what's really interesting about CI/CD is that the tools and platforms utilized are interchangeable for the most part. However, at the heart of any CI/CD workflow is a version control system, and by far and wide the most popular one used today is Git. Created by the father of Linux, Linus Torvalds, Git was originally created to manage the version control for the Linux kernel. Git splits development code from production code in what are called branches. Branches are typically used to extend applications with new features or bug fixes. Utilizing branches allows us to modify and test our code in a safe environment. When code is properly tested, we do what's called merging. This combines the development code into production code or another branch. Thanks to CI/CD tooling, we're able to add automation to any branch update or merge event. Before diving into the actual workflow, I need to quickly mention Nudge. Nudge is an open source macOS system software update tool which is steadily gaining popularity in the Mac admin community. It works by prompting users to update their devices. The reason why Nudge is so prime for automation is the way it's configured. With every new minor and major macOS version, our Nudge configuration requires an update. And while there are multiple methods to configure Nudge, we decided to use configuration profiles due to the quickness and reliability of APNS, Apple Push Notification Service. The problem being, manually updating configuration profiles each time is a very tedious and time-consuming effort. This also gets multiplied for every instance of Jamf. Enter our configuration pipeline. When Apple releases a new macOS version, we manually update our Nudge configuration. This is where the developer tools come into play. We use Git to add the change to our development branch on a local machine. We then push this change to GitLab, our main code repository system. Our GitLab repository has settings which mirror our repo in Google Cloud Platform. This kicks off something called a build trigger. The build trigger is what runs our Python deployment code, shipping the change to our dev Jamf instance. At the same time we update Jamf, we also update a Slack channel, notifying admins of the change. Should something go wrong, we send a debug message to a separate Slack channel, notifying our engineering team of the failure. Assuming there wasn't any errors, we create a merge request in GitLab, giving us the ability to formally review, test, and approve the change. Once we complete the merge, our automation is fired once more, this time shipping the configuration change to our production Jamf instance. Should something happen, we can use GitLab to revert to a previous version, which then fires the deployment automation once more, reverting the Nudge config in Jamf with a previous known good version. So, how valuable was this build automation? Well, it's updated our configuration profile 72 times since implementing the CI/CD pipeline in May. This has massively reduced the effort required to update Nudge during our pilot phase, and as time goes by, the value add will only increase. Thanks to this investment, we have come away with a long-term scalable strategy for deploying Nudge. And like I mentioned before, the pipeline demonstrated can be adapted to other systems engineering processes. If I have piqued your interest at all, I've written an in-depth how-to guide on implementing this in your own environment. This includes code samples for making the Jamf and Slack API calls. You can find this on our newly created blog, linked in the presentation resources. And if you have any questions, comments, or suggestions, feel free to reach out to me in the Mac Admin Slack. My handle is @samz_it. Back to you, Jeff.
Thank you, Sam. Forrester, Trina, and everyone at Stanford involved in these efforts. Migrating or enrolling thousands of devices into an MDM can initially seem daunting, but by scanning your environment and conducting thoughtful planning, it's possible to achieve successful outcomes. We hope you've learned something from our experience bringing Jamf to Stanford and look forward to returning for future JNUCs to share even more.